Okay, so it's one thing to graph the reciprocal of like a sine or a cosine, which are cosecant and secant. That's one thing. And this is the method we used last time. But to graph the inverse, that's a completely different animal. Now, here is what I would do in this instance. So I don't want to graph a cosine inverse. I want to graph cosine. So watch what I do. Let me try to isolate x. So stay with me here. So let me divide the 2 into the y. So it'd be y over 2. And then it's just cosine inverse of x minus 3. Let me actually write this down one more time with a little bit of space here. So all I've done is I've divided by 2 into that side to get the cosine inverse function alone. Now, I'm going to knock this out by taking the cosine of both sides to keep this fair, because cosine knocks out cosine inverse. And so I'm left with cosine of y over 2 equals x minus 3. And now let me add the 3 to this side. And it says cosine of y over 2 plus 3 equals x. Now let me switch left with right and right with left. So it's say x equals cosine y over 2 plus 3. Now look at this here. What I propose is that this makes the same graph as that, okay? They make the same graph, absolutely for sure. So to graph this is to graph that, okay? But this looks kind of weird because it's usually y equals stuff with x, but this is like backwards. It's like x equals stuff with y. But what I'm going to do is I'm going to make a table of values. But instead of picking x's, I'm actually going to pick y's. For instance, like, I don't know, how about like negative pi over 4? Or make that negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, pi, 3 pi over 2, and so on and so forth. You can just keep going if you'd like. The point is, we're picking y's, and we're taking this y and plugging it in for y, and we're going to get back some number for x on a calculator, which should be set to radians, right? And to do the same thing, grab all these y's individually and plug them into y to get some number for x. You're going to get a bunch of different x's. And then take these numbers, plot them on your graph, and connect the dots, and you're done, right? So that's one way of graphing cosine inverse. There's a different way of doing this all together, and that involves like reflections over the line y equals x. But I mean, if you ask me, this is the cleanest way of doing this, where you graph this, because this makes the same graph as that. And you might be asking, how come you didn't just make a table of values right at the beginning? Because it would have been difficult to choose x values appropriately. Because when it's cosine inverse, you can't just throw in anything for x. You have to be really careful. So that's why I turned something with an inverse into something that does not have an inverse, but it did make the x and y look backwards, which is why I picked y's instead of x's. And so transfer these points onto here, connect the dots, and that'd be your graph. The same thing over here. Let me divide the negative 3 underneath the y, and that would say sine inverse of x plus 1. Now I get rid of the sine inverse by taking the sine of both sides. These would be gone. And so the sine of negative y over 3 would equal x plus 1. Subtract the x to that side. Sine of negative y thirds minus 1 equals x. Put the x on the left and the other gibberish on the right. And then make an xy table of values. But pick a bunch of angles for y. All right, a bunch of random angles. I mean, you can go like 0, pi over 4, pi over 2, pi. And you can just keep going. You can use negative angles as well if you'd like. It just depends on what the teacher wants. And then plug all these in for y. Calculator, you're going to get back a bunch of x's. And then you take these points and you just plot them and connect whatever you have. So that's one way of doing this. Again, because we rely on sine to graph sine inverse, but x and y are switched, which is why you pick y's, and then you get x's, and then you transfer the data, and you get whatever kind of graph you get. And I noticed real quick here for the one that's cosine inverse, that they had this here. You see, I would probably choose pi and 2 pi as my y values that I plug into my table. And then, so plug these guys in for y, and then whatever you get for x, you get for x, and plot those points. And maybe even like negative pi and negative 2 pi, assuming that they're there. So maybe they're trying to help us with the pi's here. So use sines that are close, maybe like even pi over 2, and this would be like 3 pi over 2. So plug in these angles in for your y column, and whatever you get for x, you can just plot those points.